Hi guys, let's discuss about one of the important questions that frequently asked in these interviews. So that is related to the switching. So the first interview, they'll ask like how switch learns the MAC address of the source and destination, and what is the process that involved and how it actually forwards the traffic. So this is the frequent question that it get asked. Otherwise, they will ask like how switch learns the MAC address and does the forwarding. Right. For that, you need to ask interviewer. Let's consider like you have to give your own topology like this, or the ask the if the interviewer give you the topology, then you have to explain in that topology. Let's consider they won't give in like 5 to 10 routers. They mostly give with single router with two switches connected, or the two switches with the two different PC connected. This is how the simple topology will be there. Then you have to explain the how actually switch forwards the MAC address frame when it receives. So let's discuss with this topology so that you guys will be able to answer in the interview. First, okay, the switch actually will have empty MAC address table. Okay, first empty MAC address table. So I won't say it's empty. At least they will, if you have already configured trunk port here, and there will be STP messages will be BPDUs will be passed here. So this switch will know the MAC address of A2, and A1 knows the MAC address of the A1 actually. A1 and A2 MAC address they will be knowing, that is dynamically. So you need to tell interview there are two ways are available. How the MAC address are learned. One is the static, that you do a manual configuration binding this MAC address of consider AAA and BBB. So you are binding this MAC address into this port, right? So but you will not be able to use in other switches, right? Because the MAC address issue will happen within the same switch. You cannot use in the other port, only this port you need to use it. So that's a static binding. And there is one more binding is there. It's called dynamic. You don't need any manual intervention for this, but in case of static you need to manually check the MAC address of the PC and bind it to the port. So when they will use static, mostly when it's connected to the server, because when you connect it to some server, so anyway they will not mostly move unless there is a change, right? So that is the reason like they use static over here. This is the answer that you have to give it to the interviewer. Then the fourth one is dynamic, right? How it learns dynamic. So how switch learns is when the frames, consider there is no traffic has been sent between PC1 and PC2. Now the PC1 want to send the traffic to PC2. Okay, let me write the MAC address, also the IP address, and consider 1.0.0.2, considering they are in the same VLAN 100. Okay, consider they are in the same VLAN and they are also in the same subnet now. Okay, so now the traffic will be uh, initiated from the PC1 to contact the PC2. So now what happened, the process, it sends the it doesn't know the destination MAC address for now because it never contacted the PC2. So what happens for that, to find the MAC address of PC2, it will do a ARP request packet. So ARP request packet will have the source MAC, and in the destination MAC it will be in FFF. So this packet arrives in switch A as a step 1. So once it arrives here, right, the source MAC will be AAA and destination MAC will be in the broadcast FFF, because it doesn't know where this destination is. Okay, now the switch receives the frame here, and then it intercepts the frame and it opens the packet, it de-encapsulate till the layer 2 because it's a layer 2 switch, and then it checks the source MAC. Sorry, it just check the destination MAC if it is available in its MAC entry table. If it is not available, then it will do the broadcast to all the posts belong to the same VLAN except the interface that it is received. Okay, and then before sending it, it checks the MAC address table and it whether it has the entry for AAA. If it is doesn't have the entry, then it will entry into this MAC address table. And always know the switch learns the or enters the cam table. They say like cam table or the MAC, we'll say like MAC address table, right? Because we use a command called MAC address table, but it they say is a cam table. So in this MAC address or cam table, Always it learns the source MAC address only from the received frame on a port. And if it's already entry is there, it update this aging timer. So now it entries like source MAC address, it's gig, and how it is received on the port gig 0/0, and it update the timer. It's a aging timer. Okay, and now it will forward the packet out of this interface. Okay, while sending out it will not learn anything because only on the incoming interface it learns the source MAC address, not the destination MAC. Now the frame will be sent out here on this switch to A2. This is on the A1, and the process will start on A2. Now in the A2, it will start, it knows it's an incoming frame, right? So it will again check the destination MAC whether it is available and what is the VLAN that it has received. Then it send it to all the port belongs to the same VLAN except the port it received where the traffic is received, and it check for the before sending it check for the MAC address table whether it has the entry for the source MAC. If it doesn't there, then what it will do, it will add an entry over here like this AAA, then what interface is delivered, GI 0/1 and aging timer. Okay, then consider there is another PC, there are a lot of PCs connected to the same VLAN here, right? Then what happened, it sends a frame out of all this interface. Okay, and all these routers all these switches, right, all the PCs are connected, most of the PCs. If the packet it doesn't belong, it will reject the packet, it will not send a reply. Now the packet is destined to switch 2, right, PC2. So the PC2 will reply, open the frame, check it's destined for this IP address, so it will reply with this MAC address BBB. Now the traffic will come and hit switch 2. Now what switch 2 will do, it will check the destination MAC whether it has the entry. Yes, it has the entry in the destination table, MAC address table. So what it will do, it will forward the frame directly out of this interface, right? Now it knows this. There's a the traffic has been forwarding to AAA, and it has an entry in its CAM or MAC address table, right? Before forwarding it, it will intercept the packet and check the source MAC address and see whether the entry is available in the switching table, MAC address table. If it doesn't have the entry, then what it will do, it will create an entry GI 0/0 and the aging timer. Okay, and then it forwards over here in switch A1. Now switch A1 will do, it will open the packet, it check the destination MAC, it has the already the entry is there, and it has to forward the MAC frames out of that particular interface gig 0/1 here. And before sending, it will check the CAM table and see whether the entry it's available for the source MAC address on this port. If it is not there, then what it will do, it will create an entry like this. It will update the aging timer, and that frame will be sent out of this interface here now. Now the end-to-end communication has happened, and switches also learned the MAC address of both the PC and its aging timer also. So what happens if the communication is not happening between the PC for more than 300 seconds, then this entry will be removed. So if the communication is happening continuously, then the entry will be available. If the communication is not happening, it's dynamically learned, right? So okay, there is one more thing that you need to note, it's a dynamic learning, so we are not doing any manual configuration actually. So it will be if you see the show MAC address table, it will donate as dynamic, it will donate it as denoted as like dynamic table actually. Here you can see the dynamic, it will be mentioned in the output. So this is how the switch learns the MAC address. Okay, there is a second condition. The switch already learned the MAC address. Now how it will forward? When the PC1 sends the traffic, it intercept here, and then it check the destination MAC table. The destination MAC table it's already available, and it checks the source MAC. It's already available in the the MAC address table, it will just update the aging timer and directly send out the frame out of gig0/1. Then what happens in switch 2, it will again check the same process and again process the same process. It will once received, it intercept the frame and then check the MAC in the cam table. If it is already available, then it sends out of the that interface, and also it intercept while intercepting, it check the source MAC also. If the source MAC is already available in the switching, what it will do, it will update the aging timer, right? So this is how the process happens when already MAC is already learned on a switch, how it forwards. If it is not, how switch learns a MAC address and actively forward it only using dynamic. So we can also use static, that is only used for servers in the real-time production network. Let's do a quick lab later to this so that it will be useful for you to guys to understand. Okay, the same setup I have it in my lab. Okay, what I'm going to do, I'm going to log into all the devices. So I have switch 1 and switch 2. Let me check show MAC address table. Okay, here you can see that this is a MAC address of A2. Here you can say it's a dynamically learned. That's what I told, dynamic learned, and like how it is learned, it's learned via gig0/1 and is the MAC address of the switch A1. Now there is no communication happening between PC1 and PC2. Okay, now what I'm going to do, I'm going to initiate the packet between PC1 and PC2. Okay, so I'm going to do a ping 192.168.0.1. I'm going to do a one count. One. Okay, now the traffic has been initiated and it is okay, sorry, it is a local one. I need to do it for the remote and IP, which I didn't check. Okay, let me check what happened here. Show MAC address table. Okay, the source MAC, or let's check the MAC address of this PC. Okay, the MAC address is 6805. So let's see, it is 6805. It is learned here. Let's see, it's forwarded the packet out of this switch A2. Show MAC address table. Okay, so it didn't forward from between switch A1 and switch A2. So this is how you need to do a the checking. Show interface gig show VLAN. Let's see what VLAN it does belong to. Okay, so it does belong to VLAN 100. Okay, and let's check show VLAN here. Okay, for some other lab testing, I have done like 100 and 200 VLAN configured. So this is the issue. So I need to allow this VLAN into the trunk port, switch to switch trunk port, so that my traffic will be forwarded out of switch A1 to A2. And this is actually interview question, guys. In case like if the VLAN is not allowed between the trunk, what will happen? And if I created a VLAN and map the PC directly here, but you forget to configure this VLAN right under the switch trunk port. So what happens? So it will it will not forward the traffic out of the trunk port if the destination is in the another switch. So this is like explaining you guys one of the interview question also in the lab. One more thing, guys, to note here in A2, right? I did configure VLAN, but I didn't call this interface under the VLAN. But in case of switch A1, I configured this interface under VLAN 100. So for now, what I'm gonna do, instead of creating the VLAN 100 over there and calling it 100 VLAN 100, I'm gonna do change the interface configuration for the testing. or you have to correctly map. Okay, let's do it in a way. Consider this is a troubleshooting scenario, right? You're doing a troubleshooting, and you see that this interface is properly configured under VLAN 100, and you need to do the same thing on the switch 2 as well. So what I'm going to do, I have created the VLAN 100. So I'm going to call this VLAN 100 the interface gig 0/0. So switch port more switch port access VLAN 100. Okay, let's see show VLAN. Okay, now I configure the VLAN under 100 in gig 0/0. Okay, let's do a ping and see if it has worked. I don't think it will work. Let's see. Oh, it's working now. Okay, now everything is allowed. Okay, the trunk is default is allowed. So let's like enter the trunk configuration by default. Like if we don't restrict anything, right? Let's see. Okay, if you don't restrict, then all the VLANs are allowed. In case if you are restricting, then there is a chance that it will stop that VLAN sending out of the trunk port. Okay, so now we fix this VLAN issue now, wrong VLAN configuration mapping. Now we will see like show MAC address table, right? Okay, now you see this. This is the 05, right? 05 is the MAC address on our local PC here. So let's check the PC's MAC address. Show IP, right? So this MAC address is 6805. Okay, and check this MAC address is 6804. Okay, now let's check the MAC address table here on switch A1. So we can see that 6A4 learned dynamic via the trunk port, which is PC2 MAC address, right? So and then PC1 MAC address is learned via this gig 0/0, and you can say it is dynamic. They are dynamically learned. Let's go and check the show MAC address table. Okay. Now we can see that MAC address has been learned. You can see that this one, right? This particular MAC address is learned. The local PC MAC address is on gig 0/0, and the remote MAC address entry has been done on the gig 0/1 via the trunk port. So there is, I told you about the aging time, right? So let's check the aging timer also. Okay, show MAC address table aging time. So this is the max age time. Once this time is out and there is no traffic passing between PC1 and PC2, then there won't be any MAC address available. There is an option that where you can clear the MAC address table also. Clear MAC address table. Then this is a dynamic learn, right? So I clear this dynamic MAC address table also. Show MAC address table. Now you see there is no, the entry is only for the switch to switch MAC is there, and there is no host MAC address entry is there. And one more thing you need to note, now I cleared on this switch. Is there any option that switch to switch share the MAC address? No. This MAC address table is local to the switch only. It will not share between the any switches. See here I have the entry, but in this switch I don't have the entry for the host. So this switch learning process is local to the switch only. Hope it help you guys to clear your interview for the switching questions based on the forwarding of the forwarding frames out of switch. And if you have any doubt, just leave a comment. I will address it.